about the theory of logarithm. And in our lessons, lesson 1 to be precise, we talked about logarithm indices relationship, that is, how to change logarithm to indices. In our second lesson, we talked about the first 4 laws of logarithm, and in the third lesson, we completed the laws, the last 5, making 9 laws of logarithm. In the previous lesson before this, which happened to be the 4th lesson, we talked about logarithmic equations. Now, we have lesson 5. What is lesson 5 all about? Substitution in logarithm. Now, what do we need to do before substitution in logarithm? We express a number as a product of its prime factors before substitution. Again, we express a number as a product of its prime factors before substitution. Take for example, if I have 24, 24 is 2 times 2 times 2 times 3. Meaning I can multiply 2 3 times to give me with 3 to give me 24. That is 2 raised to power 3 times 3 giving us 24. Another important part of this lesson that we need to understand is the logarithm of power 10. Remember I said we need to get the prime factors of numbers before we do substitution. But if we have a number with a power of 10, like 10, 100, 1000, we need not get the prime factors. We can just take log 10 to base 10 as log 10 raised to power 1. And if you have log 10 raised to power 1, it means log 10 is 1. If you have log 100, which is 10 raised to power 2, it means log 10 raised to power 2 to base 10 is 2. If you have log 1000 to base 10, 1000 is 10 raised to power 3. It means log 10 raised to power 3 to base 10 is 3. We have log 12. Remember I said we need to express whatever number we are given in using prime factors. Now we start by getting the prime factors of 12. 2 can go in 12 and 2 is a prime number. 2 in 12 is 6. 2 can still go. We have 3. 3 in 3 will give us 1. So the prime factors of 12 are 2, 2 and 3. So I'll come here by writing this as log 2 times 2 times 3. And that will be equal to, I'll split this now. I will have log 2 plus log 2 plus log 3. The first 2 here, the second 2, and the 3 that ends it. From the instruction, we're told that log 2 is 0.3010. 0.3010. And this is 0.4771. On adding, we have 0, 0, 1. Will give us 1. 1 plus 1 plus 7 will give us 9. 0 plus 0 plus 7 is 7. 3 plus 3, 6 plus 4, that's 10. Carry 1, and that is 1.0791. If you add this, you get this. Therefore, log 12 equals 1.0791. We have log 0.72 in base 10. Now this is a decimal. We need to change this decimal to fraction. So we have log the 2 digits 72 divided by the point is 1, and we have 2 zeros because of the 2 digits 7 and 2. We have our base 10. I can split this to using the 4th law, the law of subtraction, to have log 72 to base 10 minus log 100 to base 10. Now 72, I need to express 72 using prime numbers. That's getting prime factors of 72. But I can decide not to express 100 because 100 can be expressed as a power of 10, which 72 cannot be expressed. 100 can be expressed as a power of 10, that is 10 raised to the power 2, but I cannot express 72. So I need to get the prime factors of 72. Let me do that here. 72, I have 2 in 72, that's 36. Another 2 will give me 18. Another 2 will give me 9. 3 can go, 3 in 9 is 3, 3 in 3 is 1. So I have 2 in 3 places and 3 in 2 places. So I'll come here by writing my log 72 as 2 raised to the power 3 because I have 1, 2, 3 times, I have 3 raised to the power 2 in base 10 minus log 100 in base 10. Now, separating these two using the law of addition, the third law, I will have log 2 raised to the power 3 plus log 3 raised to the power 2 both in base 10 minus log 100 is 10 raised to the power 2 in base 10. I'm doing that because I want the base and the number to have a common number so that this 3 will come to the back. We have 3 log 2 to base 10 plus the 2 also coming to the back, 3 to base 10 minus the 2 log 10 to base 10. What I've just done by bringing this 3, the 2, and this other 2 to the back is I've applied law 5, which states that anytime we have a power on a number, the power can come to the back of the log. So I have 3 from the question, log 2 is 0.3010 plus 2, this is 0.4771, that is for log 3 according to the question, minus 2. Log 10 to base 10 according to log 2 is 1 because the base, the number, they are equal. So multiplying this, we have 0.9030. Multiplying this, I will have 0.9542 minus 2. If I evaluate this, I will get minus 0.1428. Therefore, log 0.72 equals minus 0.1428. Now we have log square root of 35 in base 10. The 35 is with a root. The first thing I will need to do is to remove the root that is protecting the 35. And from our knowledge of indices, that will be 35 raised to the power of half. The square root will turn to the fractional index half with our base 10 as stated in the question. The half will come to the back of the log according to law 5. So we have 1/2 log 35 to base 10. Now I will express my 35 using prime numbers. So that means I'm getting the prime factors of 35. The prime factors of 35 are just 5 times 7. So I can add this to be 1/2 log 5 times 7 in base 10. And that will be 1/2, a big bracket, 1 for log 5 in base 10 and the other for log 7 in base 10. Closing the bracket now. According to the question, log 5 is 0.6990 and log 7 is 0.8451. Adding what we have in the bracket, we have 0 and 1, 1, 9 plus 5 is 14, 9 plus 4 is 13 plus the carried 1, 14, 6 plus 8, 14 plus 1, 15. We have 1 point less. Half of this will give us 0.7721. Therefore, log square root of 35 is 0.7721. example to get log 60. Let us get the prime factors of 60. Start by getting 2 in 60, 30. 2 in 30 is 15. 3 in 15 is 5. 5 in 5 is 1. So we have 2 twice. We have 1 3 and 1 5. So I can take log 60 to be log 2 raised to power 2 times 3 times 5. All in base 10. So that will splitting this using the third log. We have log 2 raised to power 2 to base 10 plus log 3 to base 10 plus log 5 to base 10. From our log 5, the 2 will come to the back of this. We have 2 log 2 to base 10. Others, they do not have power, so we leave them as log 3 to base 10 and log 5 to base 10. According to the question, log 2 is 0.3010, log 3 is 0.4771, and log 5 is 0.6990. So multiplying this, we have 0.6020 plus 0.4771 plus 0.6990. Adding everything, we have 1.7781. Therefore, log 60 equals 1.7781. In the second part of this example, we have 0.8891 equals 60. When we have a question like this, when we have the base, we take log of both sides, the logarithm of both sides, so that we have log x raised to power 0.8891 is equal to log 60. From the fifth law, the power can come to the back, so we have 0.8891 log x is equal to log 60. So that our log, we can divide both sides down by 0.8891. 0.8891. This cancel this. I have log x. In the same example, the first part, we've gotten log 60 as 1.7781 divided by 0.8891. If you divide this, you will get 2. It means log x to base 10 is equal to 2. Changing this to indices, the base 10 raised to the power of 2 is equal to the number x. So that x is equal to 100. Finally, we've come to the end of this lesson. Not just this lesson, we've also come to the end of the topic, the theory of logarithm. This is just one of 5 lessons. If you've actually missed out on the 4 lessons, I would advise that you subscribe to the YouTube channel, William's Guide to Mathematics, so that you can be able to access the previous lessons. There are 4 lessons. The first lesson was all about the logarithm indices relationship. The second lesson, we focused on the first 4 laws of logarithm. The third lesson, we talked about the last 5 laws, meaning we have 9 laws of logarithm. And the lesson before this, which is lesson 4, we talked about logarithmic equation. In this lesson so far, we talked about substitution in logarithm. And in substitution in logarithm, we said we need to break the numbers into prime factors. However, if it is a power of 10, we can work with that without breaking it into prime factors. Remember to subscribe to the YouTube channel. Press the notification bell so that you get a notification anytime there is a video from William's Guide to Mathematics. This is not the end of William's Guide to Mathematics. We have so many lessons to learn from this channel. I will encourage you to stay tuned to this channel by subscribing once again. But before then, we have some practice questions as regards our lesson for today. I would like you to take the practice questions, take a pause of the video, then check your answers after solving those questions. I'll see you very soon.